Simplifying algebraic expressions. Alright, so we've got some vocab for this lesson. Our first vocabulary word is terms, and that is just any one of these combinations of a number and a variable, or just a number or just a variable. Okay, and these, each one that's separated by addition or subtraction, these are two separate terms. So this expression right now has 1, 2, 3, 4, 5, 6 terms. Okay, if I included in here like p times 7, that would not change the number of terms because this is not separated by addition or subtraction. This together would be one term, right? Like terms are terms that share the same variable, okay, or lack of variable. So my like terms here would be all of the ones with a in them. And then everything with a b would be a different like term. Every just number without a variable would be a different like term. And then all my p would be different. Okay. One thing to add on that, if I had a exponent, so if this is like 3a squared, this is now different. This is a different term than these a's. This would now be a separate term, and I can't combine it with these two terms. Okay. All right. Equivalent expressions are expressions that look different but can be simplified to be equal, or if I put in a value for my variable or variables, they will be equal as long as I put in that same value. So like right here, if I put in 2 for x, I'd have 3 times 2 plus 2, or 3 times 4, which would be 12. For this one, if I put 2 in for x, 1/2 of 2 would be 1. 1 plus 1 would be 2, times 6 is 12. Okay, so these are equivalent expressions. They look different, but they give the same result. When we're asked to simplify an expression, we are going to combine all the like terms that we can and complete all possible operations. Okay? Until we have a value to put into our variables, though, we can't complete these additions, right? We can't combine these terms because they're not like terms. They're different. This x could be 1,000 and this y could be 1. Okay, so I can't add them together until I know what they are. All right, so this would be a simplified expression for this expression. All right, concept 1 is combining like terms to simplify. Our step-by-step process is identifying like terms first, okay, and then we're going to move like terms next to each other. All right, so when you're identifying like terms, you can draw a square around one kind of term and a circle around another. Whatever works for you. I like to do a little underline like that with different colors, but if you don't have different colors, that's fine. The big important thing to note on this is whatever term is to the left goes with your, whatever sign is to the left, or whatever operation is to the left, goes with your variable, or with your term. So this W has that minus or that negative sign that needs to go with it if I ever move it. Okay, my 3a, I want to remember that that's a positive 3a. And then same thing for my positive 2b and my positive 10b, and then my minus 6. Okay, when you're thinking about these, if it helps, I like to use fruit as an analogy. Okay, I imagine that this 2w is 2 watermelons. Okay, Say we're making I don't know, a fruit basket, or we're taking fruit to a food shelter. Okay, so one student brings in 2 watermelons, the next student brings in 3 apples, the next student brings in 2 bananas. Okay, but then something happens and one of those watermelon breaks, right? Or maybe we decide that we're going to eat one of the watermelons. Okay, another student brings in 2 apples, somebody brings in 10 bananas, and then maybe this 6 that doesn't have a variable there, maybe that was dollars, right? Maybe we spent $6 buying some extra fruit or something. Okay, so we have kind of a situation where different things were added or taken away, and we want to figure out, okay, how much fruit did we actually give to this food pantry? And that's where we're going to combine our like terms. So we've got them identified, and now we're going to move them. Okay, so I've got my 2w minus w. So I start with whatever variable I have, whatever type of term, and then I find the next one. Once I'm done with all of those, I go on to my next term, my next different type of term. So now I've got a plus 3 apples, and I added another 2 apples. Okay, I'm done with the apples, done with the green. I had a plus 2 bananas, and I added 10 bananas, and then I have a minus $6 or whatever. Okay, and now it's pretty easy. You can just add your like terms. If your variable doesn't have a number by it, it's a 1. Okay, so this is 2w minus 1w, which would leave me with just 1w. 3a plus 2a is going to be a positive 5a. 2b plus 10b, positive, go back, positive 12b, it's getting a little scrunched, and then minus 6. Okay, so that would be all the fruit that I gave to the fruit pantry. I gave 1 watermelon, 5 apples, 12 bananas, and it cost me $6. Okay. All right. So now let's go on to another one. We do have some exponents here. Remember, exponents change the term. Okay, so this x squared and this x are not the same term. All right, so I've got 2x squared. Right here I've got a negative x squared. I've got a negative 3x, and a plus 5x, and a plus 6x. And then again I got a minus 17. Okay, so rewrite 2x squared minus x squared minus 3x plus, and this is actually something you can do. I'm going to go back a step, especially if you have a hard time with negative numbers. You write your positive numbers first. So I've got plus 6x plus 5x minus 3x minus 17. And that way when I go to add them, I have 2x squared minus x squared, which leaves me with just x squared. And then I have a plus 6x plus 5x, which would be 11x minus 3x. So that's going to be a positive 8x. Okay, and it's easier to deal with adding them and then subtracting from a larger number. So you can set that up. And then just pull down your minus 17. And that's it.